Hi, everyone. This is Jules Urbach, the CEO and founder of OTOY Inc. And we're going to talk about the future of GPU rendering at GTC 2021. So it's been about 11 years that I've been doing these talks. My very first one was in 2010. And my 10-year anniversary of GTC was last year. I did 2 talks, one in the spring, one in the fall. And there's always so much to discuss in the world of GPU rendering and where the future is going. You know, GPUs have been this transformative force in the data center for artists and creators, of course, AR and VR and the metaverse, so many different things that have become possible with rendering and graphics and compute really all come from advancements in GPU rendering. And it's been an honor every year to talk about the state of the art at GTC. So OTOY's mission in all of this is to create the tools for content creators, artists, and the like to democratize content creation, to use the power of GPU computing to deliver tools like Octane for rendering, and also other services that are related, such as light stage scanning for assets, and ultimately in the more recent phases, cloud rendering through our render service. But let's focus on Octane for a bit. It's been about 10 years since the very first version of Octane was released. We had our 10-year anniversary launch of Octane last year, and every 2 years, we've had major advancements that have taken it from images to animations to finally production rendering, and now more towards real time. But let's take a little bit of time to look at what's been done in Octane commercially the last few years. You may recognize some of these scenes from TV shows and films. Let's take a look. Beautiful work. Absolutely beautiful work. And one of the things that's really nice about Octane is that you can do renders all in camera. This is a render from the title sequence for Ant-Man and the Wasp, our very first Marvel movie done in Octane. And that film was done not only in camera for every single shot in this title sequence, but also I think it was the only sequence in the film that was rendered left and right eye separately. And it was done on the cloud. So a lot of converging things in our ecosystem in this particular shot. And again, Octane was used for the title sequence in Captain Marvel. All stuff that we're really proud of. And you have to remember, this is all on the GPU. So GPU rendering used to be a thing that was very tough to sell people on, not so much anymore. That's definitely a great trend to see over the last decade. Let's talk about the Octane ecosystem. We've integrated Octane in over 24 different 3D tools. We package that all together in one very low price subscription. It's about $20 a month. And in certain cases, it's actually free. But all of them can integrate Octane as a render and also import and export OrbX, which is our open source interchange standard. We've also integrated Octane in game engines like Unity. It's free for use in Unity since 2017. And in 2019, we released Octane for Unreal Engine, also free. And it brings the power of GPU production rendering to these 2 game engines, which are themselves now evolving into more DCC-like tools. Their convergence between game engines and 3D tools is very interesting. We have a lot of users of Octane and C4D that are experimenting with Unreal and trying to use our 2 plugins together. And we'll see where it goes. I mean, it's definitely a new world out there where real-time and game engines and all of those things are being used for productions and even final frame renders. And we just want to sort of service both sides of that industry. Those that are making real-time simulations with game engines that could use our quality, and of course also delivering real time to artists in traditional cinematic pipelines. We've also developed a Hydra render delegate of Octane. This is it running inside of Houdini Solaris. We'll be talking a little bit about that further in the talk. But let's next look at the last year for Octane and what features we rolled out and where things are at. There's actually a couple of great features preceding 2020, like being able to have OSL shaders inside of volumes, which shipped in 2019, but that was put to even greater use in the 2020 version. And as we look at 2021, which was released almost exactly a year ago as a GM, some of the great features that were added in there, we licensed the Cinema 4D noises from Maxon, so you can now use those on the GPU. You can see that being shown here. You can use that for volume displacement, which is also a feature that is new to 2020. And we improved Vectron to support volumes. The art tools for that are actually still pretty new, although we have some amazing art being done with Vectron. We want to sort of create more tools inside of the DCC toolchain to allow Vectron volumes to be leveraged. But you can see here, you can take shader toy examples and turn that into Vectron. It's all OSL sign distance field based primitives right in the renderer. When you do have that interactivity, though, you can see here, you have very powerful operators just by interactively moving different shapes together. You don't need to worry about geometry with Vectron. It just creates these absolutely perfect ray traced objects, both volumetric and solids, that are procedurally defined. And so I think that, one of the questions I got in an earlier GTC panel was, what is the future going to look like? Is it going to move beyond triangles and polygons? And I'd say things like Vectron show how that future can look. Shading, let's look at subsurface scattering. Random walk, we added that on the GPU for Octane last year, and it looks great. This is a test in Blender done by Lino Grand, who develops and operates the community around the Blender plugin. Random walk's really fast in Octane, and it's beautiful. It's a great technique and something that we're really excited to have, working for users this past year. Do some great stuff with it. We've also improved the universal hair material in Octane 2020. It'll be improved a little bit further this year as well, but it's been great for hair rendering. Volume displacement, another important feature in 2020. I showed a little bit before with the Cinema 4D noises, but now in Octane it's also very fast. And we also added a new dirt shader, which is basically ambient occlusion with a lot more control inside of a shader in the node graph. Another important feature that was missing in Octane for almost a decade, but is now in there in 2020 and later, is we have light primitives for quads and spheres, and those do sample 4 times faster. So a lot of the rendering in Octane 2020, a lot of artists are noting that it's a lot faster. Well, it's because we just added these primitives, and they should have been there before, but we didn't want to introduce any bias in Octane. Now you have the best of both. You have this very fast speed for these primitives. You have the ability, there's a node shipping in Octane 2020.2, which allows you to control the spread function for these quad lights, and they resolve very fast. We also added native curve and point primitive attributes, highly requested feature, and introduced changes to the universal camera, which is our compute-based camera system, so you can have things like split focus diopter, many other really cool features. We're probably nowhere near done with the things we can add into the universal camera system, but it's great. 2022 is a newly released version of Octane that was initially rolled out late last year and is now Gold Master. The great features in there include much faster support with Optic 7 and RTX. It is up to 1.6, 1.7 times faster with things like the dirt shader. Overall, Octane Bench, which we're just about to release for 2020.2, is just 10% faster. I mean, we're now over 700 Octane Bench for an RTX 3090, which is fantastic. It was in the 600s before. As we look to the future, what we're seeing is there's a lot of scenes that we're looking at for improving Octane Bench, and most of them are running much faster than Octane Bench is indicating, which tells us that Octane Bench is pretty conservative. So we're looking at about 40 scenes to make the benchmark more balanced, especially with user scenes, real scenes that are coming from modern pipelines. And when we add those in, we might end up in Octane 2021, along with further performance improvements, with something that is likely going to be closer to 1,000 Octane Bench on a 3090. We'll see how that plays out, but If anything, you can consider OctaneBench to be a pretty conservative measurement of the real-world performance of your GPU, at least on an Ampere card. So let's talk about some of the features that were inside of 2020.2. We added nested dielectrics, which is really important for light passing through volumes in different mediums, like water and glass. Looks great. A lot of input from users around shaders. There's a lot of OSL shaders out there, but a lot of users just wanted us to bake these into the core. So we have UV distortion textures in there. We also built a system that's difficult to do just in OSL. It's called Chaos Texture Mapping. It does really seamless tile mapping in Octane. It's a great feature. Users love it. And we finally got an update to the XParticles SDK for the Cinema 4D plugin. So we can now do XP Trail colors and many more things that are being added to that plugin, which is great. New gradient tools, a lot of the native OSL shaders that were in LiveDB, we've just baked into the core of Octane. So channel splitters, ray switch, a lot of logic and state nodes, they're just in the core, and more will be added. We've also been working on ASIS, CG, and color management. That's going to be wrapping up in the next couple of months, actually, but a lot of that's already in Octane 2020.2. It'll be fully finished in Octane 2021. We've also started to work on basically, kind of the minimum pieces of what you get from Photoshop. And of course, things like a light mixer inside of the core Octane node graph, so that you can do a lot more compositing with your EXRs and the final renders, even on cloud rendering jobs. That's important. But also, users have been asking for multi-light for ages. So now that's built into Octane. We're actually working on making it even simpler with macros, but with just the pieces we've added in there and the ability to take your AOVs, like your wireframe AOV and different the position maps, right? You can blend those together in the compositor node graph to do custom AOVs, debug AOVs, and this is all in Octane 2020. It's not even the more fancy features that we're adding in 2021, but it's really cool. And it also means that when you're doing a batch render job from the core of Octane, you now have a lot more features that you can just do in camera, so to speak. Fast fog is one of them. Really easy to set up and do that in the AOV system that we have in Octane 2020.2. We've been teaching that for a while, but really the way to do this is to do it inside of the AOV system and to come up with many more macros that make it simpler to do that from a high level, but it's very powerful. And as we look to take what's been very popular in our C4D plugin, which has been Octane Scatter, and bring that into the core, we've actually been coming up with many cool features that shipped in Octane 2020.2 for scattering using Vectron objects. It's also really fast, and we are looking to basically bring scatter to the core and onto the GPU so that we can leverage things like Vectron and really complex ray-traced operations for scattering, which is something that's been difficult to do in Octane Scatter to date. Some of that's gone through the CPU. It's also been dependent on the DCC host application. So we're looking at ways of improving that, at least in certain corner cases. Let's now look at Octane 2021. So Octane 2021 is in closed beta. It'll probably be in Gold Master around May and release candidate in about a couple of weeks. A lot of great features in this release. There are about 200 users on the closed beta right now. Geoclipping, really fast, all done on the GPU. It works great, and it's a great feature. I think you could do a lot of really interesting Boolean model operations right within the core now. We also have a new light sampler. It's 2 times faster for AI light and direct light sampling. We're also, in 2021, starting to leverage the RTX hardware motion blur. So you're going to see about 1.5 times faster speeds on skins like this one. 2021.1, which is shipping soon, has instance. In other words, object motion blur, and then later in the year we'll be adding support for vertex deformation, hardware accelerated motion blur as well. Top requested features coming in 2021 in the next release are volume light linking. We've gotten rid of the 4x volume overlap limit in volumes that are the same step length. It's now, I think, over 16, so it's much higher. And we fixed issues with invisible lights and volumes. All those are actually in the release shipping in the next week or so. We've also done a major overhaul of the AOV system in Octane with 2021. This has been a long time in coming. We talked about it a bit last year, but now it's finally in a near finished form in Octane 2021. And you can create any AOV you want as shaders, as global textures. You can create object masks. All of this is programmable, much more powerful than what we had before, and great for compositing. And of course, you can use the built-in compositor in Octane to create many composited frames right within the core renderer in the IPR window even. But so much more that you can do with that. Another feature that's we're actually happy to ship soon in 2021.1 is USD support right in Octane. So you can have USD proxies. That'll work great and really important. We're going to make Orbex itself export USD and import it. That'll be the core mesh format in Octane Interchange, which is going to replace Alembic and OBJ and FBX and others. Let's look at the larger roadmap now. We still have work to do in the core. 2021.1 has some of that work in there. We're already doing a lot of work in terms of stability improvements. I think even 2020.2 people have been really happy with the stability. And latest drivers from NVIDIA have also helped with that. But as we go forward through this year, we want to provide support for running Octane itself in a separate process. We're doing that in Blender, and it does mean that when Octane crashes, the host application won't crash. And we want to bring that to all DCCs. There's going to be more work being done on the automated error reporting system. And we're also going to bring the denoiser to CPUs. We have that working on the map, but we're going to make that work on all platforms. That'll help as well when you're running on older GPUs and there's a lot of heat or power consumption. That does cause some instability, although again, latest NVIDIA drivers have been less of an issue. We're going to harden out-of-core memory. We're going to provide even better support for NVLink, and we believe on a 3090 you're going to have billions of primitives that'll fit in core or with NVLink, which is something that we would love to see. And we're also going to do things to improve memory management around converting images to grayscale when we single flow channel when we know that they're grayscale, for example. Some fixes going into the volume rendering passes or pieces of the engine, again related to being able to ignore volumes for the focus picker. Another user request making random walk medium work better when the surface is not transparent. And then we're also adding support for mesh divine. This is inside of our tool Sculptron, but we're going to be bringing that to the core of Octane as well. So the roadmap for this year, as usual, is coming from users. We've been asking users since Octane 2019, really, to just give us their top 10, and you guys have been doing that. We've been, we have a great list. This was again from just a couple of weeks ago in March. Number one things people want, number 1, 2, and 3, and 4, and 5 are all listed there. Brigade, better AI denoiser, faster RTX speed. So, they're all things that are in the mix. One of the things that's coming in 2021.2, which should probably hit by the fall, is curvature node. We've also completely rebuilt the AI denoiser. It's 2 times better. You can see the 2020 versions in the middle there, and on the right is the new one. Same number of samples, double the quality. So just again, retraining the data set and improving the volumetric and the spectral denoiser just provides great results. We're also improving the shatter terminator for low poly objects. That's in progress. And then we have features that that may ship sooner than later. We're supporting MIP maps, adding parallax occlusion maps. This is possible in OSL, but we want to make that work in core. Rounded edge textures is in development. Volume user data attributes, that's been a big request. As our rest position input for Houdini users, that's coming. Additive materials for pure emissive materials that you can stack together, also coming. Another feature that probably will ship by this summer is multi-scattered GGX, which will be energy preserving, and tail blurring factor for GGX BRDFs, which is something that architectural rendering users have been asking for a while. That's shipping soon. We have a new fabric material and BRDF that's in development. You can see even the old fabric rendering Octane, which is what you're seeing here, is looking really good. So it'll be even better with the new system. Light path expressions, a number of things continuing on the AOV work that's been done in 2021 will ship later this year. And AOV driver nodes that are basically following the way that Arnold does AOV drivers, which is a great system. We want the same in Octane. Post-processing, we're going to revamp the imager nodes. You have some pretty powerful features in the current system now. You can pass things through OSL, for example, and do a lot of interesting shaders there, but we want to just make a built-in imager node that has a lot more in it. That's in development as well. The compositor node graph, it is 75% done, but we want to make it really equivalent to what you can do in a traditional sense with Photoshop, so that all of that works. That means having layer filters and all those things be in the compositor and make that explicit. So even using Cryptomat, for example, to do masks within the compositing graph should all be possible, and we think all that will be done by sort of the fall in 2021. Speaking of post-processing, we definitely want to add AI style transfer. This is an example done to great effect by our own users, sort of outside of Octane, but again, this is something we want to support in there. Rendering and motion sampling, lots of fixes that are in development, including multi-region rendering, depth of field on off toggle, and lens effects. Those are been in development since last year. Some of them are easier than others. We have two modes for chromatic aberration. One of them is basically done almost in post. The other is done inside of Octane itself, which is interesting because it's a spectral renderer. So that's in development for later this year. And these, again, are improvements just in general to motion blur for texture displaced objects and HDR environments and the like. The time node is something we need to do for Urbach's proxies. It's been something that's been in development for a while. It's been pushed back a bit because some of the other features keep getting voted higher, but we do want to get it in there and want to have the ability for the core node graph to be able to control time and time envelopes, especially when you're dealing with proxies coming in. For geometry, adaptive subdivision of vertex displacement's been sort of an ask that we want to get done this year, and new parametric spline and curve primitives. There'll be some other updates on that later in the presentation with a new tool that we're bringing to Octane. Smooth tangent support, also for Houdini VW packing. These are things that are probably, again, later in this year. Spectron, we want to have more types of lights, paralight, parametric spotlight, disk and tube light primitives. These are things we've been testing actually in Brigade. We're also looking at doing a proper mesh light. Right now you just make materials emissive, but having a mesh material might be faster. And again, we want to sort of mimic the Arnold light system, which is great. There's a lot of convergence we want to have with the way that Arnold works. We're actually closely partnering with them on a number of things, which we'll be talking about shortly. This is one of them. Again, having Spectron OSL filters for light decay, these are things that are kind of doable now, but we want to make that simpler. Having a light manager in Core makes a lot of sense. There is one now, a newer one in Cinema 4D, and the plugin there is showing to great effect how that could work across the entire ecosystem. And we want to have also a built-in particle shader system with scatter and Spectron being used together. You could do a lot of things that are similar to what you can do in Touch Designer with GLSL vertex shaders, and that work is also in mid-development, I would say. We also want to provide a system for basically shader-based displacement that's super fast. Like right now, you can use OSL shaders to do vertex displacement, but it goes through host memory, and we want to do it all on the GPU. So that's what Vectron displacement's about. It'll basically allow you to do the equivalent of GLSL vertex shaders, game engine shaders on the GPU, and still be super fast. And then we also want to have Vectron scatter nodes. This is in development, and also develop something like geoscatter. And we've actually had some early tests of that since last time that we're showing here. It's converting a mesh into essentially a bunch of hair nodes, if you believe that, with Vectron geoscatter, and it's already doing some really cool things. It's probably later this year, but it's coming, and it's making pretty good progress. And we also want to have sparse volumes controlled by Vectron shapes and primitives. So again, that's in development as well. The other thing that's becoming important as we've added, for example, Boolean operations and the clipping system is OSL trace sets. So again, that's probably about 8 or 9 months out, but it's on the roadmap for sure. And then, we are definitely looking at bringing back OSL closures. This was something that was inside of Octane 3 briefly. We took it out. It just makes a lot of sense to try to take the material layers that we have and provide more nodes to make the equivalent work in the node graph. But we're looking at doing both. And then we have things that we've been showing for a couple of years, which are in internal builds of Octane, such as fluorescence, phosphorescence, polarized lighting. These things again get pushed back because users keep asking for other features first, but they are definitely far enough along that we could put them in there within 3 months' notice. We just we'll see where they fit into the pipeline. The other thing with polarized lighting is that it does have a slight decrease in speed, but again, on Ampere cards, it might not matter. So we're looking at maybe rolling that out once the majority of our users are on Ampere. And to date, by the way, 55% of Octane users have a 2080 Ti, which is pretty impressive. So that's where the average user is in our ecosystem today. They have a high-end 2000 series card with RTX. So really interesting for us to track that as the Octane ecosystem keeps growing. One other feature that we showed earlier, which is also in development, is basically taking the entire Cinema 4D UX system, which a lot of users love, and bringing that into the core. So Ahmed, who's developing your 3D plugin, turned that entire system into a module that can run inside of Octane itself. And that means that the IPR and the node graph, if you want to see that, for example, in the Houdini plugin, now could happen. So that's in development. Later this year, we're also going to be rolling out work on a new kernel. It's based around a technology called progressive photon mapping. And PPM is a hybrid kernel that allows you to do really great caustics. So on the left, you're seeing basically a projection map that allows you to do really fast caustics. On the right, you're seeing PMC, which is a special kernel in Octane that's designed for doing really complex light transport for caustics like volumes. And the great thing about PPM is it allows you to do the speed of the former, the quality of the latter. And it's something that hasn't quite been done on the GPU before, but I'm pretty sure we're going to get it working, and it'll be a great feature for these kinds of scenes. It's also going to be used for baking irradiance. There's going to be cases where we may want to do that. Not always, and I think, frankly, the world's moving towards unbiased rendering, but there are cases, for example, in Brigade, where the PPM kernel and the irradiance cache it generates could be something that is used for real-time scenarios on lower-end devices, which we'll show some examples of on the line. And in terms of third-party support, we're absolutely adopting Arnold standard surface, and in fact, a bunch of Arnold nodes, we're working closely with Autodesk on that. And it looks like, in addition to USD, Material X is going to become a pretty industry-wide standard. It's so close, frankly, to the Octane material system already that it won't be hard for us to do that. And then we're also doing a lot of work around Hydra, which we'll be presenting a little bit later in the talk. So let's talk about Render. Render is a whole other part of our technology stack. It, of course, is conjunctive to Octane, but it is a cloud rendering service. It is a distributed GPU cloud rendering service. It is powered by individual machines and nodes out there in the world. Inspired, of course, by many blockchain-based systems, right? Like Ethereum blockchain mining. It's using a decentralized set of nodes, and there's hundreds of millions of GPUs out there. The problem is we've had cloud rendering for years running on the public cloud, but there's less than 50,000 GPUs in the public cloud, and that is not a lot. It sounds like a lot, but it isn't. And so the kind of service that we can build on the decentralized network that's powering Render is phenomenal. Phases 1 to 3 took a few years. We started Render, officially in 2017. It's been in beta for 3 years, but we basically migrated the token that we created for Octane Cloud Rendering Service, the one we launched in 2015, and we mapped it to a Ethereum token. And basically, dollar for dollar, at a minimum, it does the same work that you would pay Amazon to do, but it does it on individual machines, and we pay them out for that work. And it's great. It's really easy to set up Render. It's a system applet. You just run it in the background like SETI at home, and it does its thing. And here's the interface for those that haven't used Render yet. It all runs from a web page. You can export an ORBX file. You make sure it runs in Octane standalone. Then you drop it into the web page, and it just sends it out into the onto the blockchain, and it verifies that the render that you want is being done. That's why there's a watermark on there. It's a little bit like having Uber, but for GPU rendering. In other words, you sort of connect to a node out there that's doing the rendering for you, and they deliver back a result. And when you say it's what you want, the watermark gets removed, they get paid, and your render gets made available to you. Let's take a look at this this video. So all of that was done on the decentralized blockchain. It was fantastic. It just shows the power of decentralized rendering. It was cheap. It was fast. People really love the render service. When we launched, fortuitously, we had a great first customer. It was John Knoll, the creator of Photoshop and legend in the graphics industry. He was doing a job for the Hayden Planetarium. And so many things were validated by having him as our first customer. The security of the system, if it's good enough for John Knoll, right? I mean, it is something that is really wonderful to kick off this launch. And the launch, by the way, was almost exactly 1 year ago, April of 2020. So we've had a pretty great year. In that 1 year, we now have 10,000 active users on Render. And we've paid out about 1 million render tokens for these jobs, and that's growing fast. I mean, most of that has been accelerating in the last 2 months. In fact, I think in 1 month we did half of the jobs ever done on Render in March. So it's accelerating. More importantly, I think users are really happy with the service. This is, and you're seeing it done in commercial work. This was deadmau5's video that was done all on Render. In fact, sometimes we don't even know some of the commercial work that's done on the blockchain service because we don't see it. We just let the customers run it. But the reactions have been fantastic. I mean, I have to say that as much as people love Octane, I think people love Render even more. And that's great. I mean, they're both our babies, right? We're seeing, again, that we've hit the sweet spot in terms of cost and speed. And really, the goal is from this point onwards is to grow the system. But I think we've done a very good job of keeping it, relatively small. We onboard certainly on the node operator side carefully, so that we don't have too much rendering power that's just sitting idle. And we've also wanted to make sure during this last year that the art pipeline has worked really well for everyone, so that by the time we do bring on 100,000 artists, not just 10,000 or maybe millions, because we are opening it up to everyone, that it's going to work perfectly. In the recent weeks, in fact, just last 10 days, we've launched V6 of the render client, and it actually is a huge release. It allows support for Ampere cards finally. It brings Octane 2022 to Render, and it allows support for multiple Octane render versions. And it also means that we can have other things besides Octane running on Render, which is pretty cool. We've had some major partnerships also announced this year for Render. One of the big ones is Polygon. They create a system on top of the Ethereum blockchain that we're using that just makes Ethereum for Render work a lot more efficiently. And Ethereum is just slow. If you've ever looked at how the blockchain works, it's expensive. It uses a lot of electricity. None of that is good. We didn't want to have any part in that. So with Polygon, we're able to leverage Ethereum, deliver what we were doing to the last year, but so much cheaper, so much more efficiently, which is great. We've also been listed on some larger exchanges like Wowbee, and we've also we're not associated with NFTs. Many NFTs are actually generated on Render, which is great. We'll talk a little bit about those as well. And I would say probably the largest partnership that we announced in the last year was with Autodesk Arnold. Arnold is coming to Render officially, and we're so excited by that, as is the Arnold team. And it means a lot of really big things for all parties involved here. For one thing, it's really a proof for us and for the industry that Render can support more than just Octane. It's bigger than Octane. It is much bigger than OTOY. But secondly, this is work that we've always wanted to do with the Arnold team to help figure out how to make industry standards that really practically work between multiple renders. And in our case, we're taking a lot of what's in Arnold. I mean, we love what they're doing, and we're just making it a part of Octane. And they've created standards around things like standard surface, which are great. And we're probably about 4 or 5 months from having that fully supported inside of Octane. And the goal with this is that when you're creating a scene, whether it's being designed to render inside of Arnold or Octane, it should just work. It should be using open standards that allow that interoperability to happen. And I think that when the two of us, or between these two renders, when that works, you'll see it also supported much more easily between other renderers, and that'll make onboarding other renderers on Render much more straightforward. The initial release of Arnold for Render will just allow you to do standalone Arnold jobs, but we're also going to allow that to be used within Orbex files as well down the line. In terms of how you pay for Render, well, one thing, I mean, our first goal was that we wanted to fully replace Orc, which was you paid in dollars and you ran it on Amazon. We have an enterprise tier that does that for those types of jobs, the same security, but we also during the beta for Render, realized that people still need to pay in dollars. Not everybody can go to a token exchange or a cryptocurrency exchange and buy Render tokens. So, it was very clear we needed to have that. It's basically a temporary situation, but credits are a really simple way for artists to pay for render jobs. And essentially, the render credits can just be purchased through your existing credit card that you purchased your Octane subscription from. And it's just a lot simpler than crypto wallets. Now, that doesn't mean that you can't do both, which is what we support. But the way that a credit is based, it does basically a minimum of a penny of Octane Bench per hour, right? Something like that. And a credit's about $1. So it's about the same as what it still costs to do on Amazon or Google. We can also, though, use those credits, convert them into tokens on the fly for the faster tiers that Render supports. And in fact, there are these two tiers. There's the public tiers, which are just running on decentralized nodes. They're not the same level of security that Amazon or Google have for Marvel movies, but they're really secure. Everything's end-to-end encrypted. But for those Marvel films and the like, we do have the enterprise tiers, which are TPN certified nodes. Those can run really high-end, high-security jobs. But I would say that 97% of the work that we're going to see done on the cloud is going to be done on these public tiers. And even, for lots of commercial work, that security is really good enough. On the public tiers, you do have the watermarking system I mentioned. You can optionally now get rid of it because there is a trust score that goes along with nodes, and a lot of users are just fine, supporting that. So again, we added that as a feature. And if you're using these public tiers and you're using that to pay in tokens, we support the popular MetaMask browser extension, which allow you to basically pay for these jobs directly from your crypto wallet, and that works great. So the tokens themselves deliver a minimum of 25 Octane Bench. It's about 25 cents of public cloud power, but in practicality, a single token, it delivers much more than that. We just started off right off the bat a year ago, setting it to 4 times to 8 times that power. And we can change that multiplier to much larger. I mean, if the token price in the open market goes up, which it has recently, well, then we can make those multipliers 40x or 80x if the token price, the free market determines it to be 10 times higher. We're going to probably end up doing a rolling average, looking at what the token price is out there on these exchanges, and then just adapt accordingly. But that means we will always have a very healthy balance between the value proposition for artists that are paying for rendering on the render service, and also making sure that those running render jobs on the other side of that are equivalent to miners are getting paid out something that is more profitable than other cryptocurrencies and also much higher than their electric bill. That is an important consideration. And right now, I think we are supporting both really well on Render. The enterprise tiers, again, are really high-end systems. In certain cases, you just may need 40 gigabytes, right, of VRAM, and that exists on Google GPUs, for example, that have the A100s. You can link 16 of those together for 500 gigs of combined NVLink memory. And we have partners that are just for those tiers. And in fact, some of them are ones that worked with us on Orc, but now they're explicitly available for these types of render jobs on Octane Enterprise. And in addition to ourselves, we have a data center that is used for really high-end studio work that we do for our own customers that we're doing shoots on with Lightstage. We have Microsoft officially joining Render. They're actually a node that is on the enterprise tier, but also they're working with us on improving driver support on Vulkan, and also about bringing some of their decentralized file technologies to render nodes, which is really cool. And there is a lot more collaboration that we see ahead with Microsoft, both on the Azure side of things and just even on Windows itself. Google officially joined Render as well. There are some unique opportunities for our enterprise users running Render on GCP. In fact, this top score here on Octane Bench is from a 16 A100 system, which is about 8,000 Octane Bench, which is pretty crazy. And yeah, there is Adrian who runs GCP and has been pretty excited that his system that he designed is the top score on Octane Bench. So yeah, the A100s, I mean, there are certain types of really advanced scenes and high-end renders that need that kind of system. If you were just to pay for that outright, it'd probably be $70 an hour, and that's about what the cost in Render credits is to pay for that system. The roadmap ahead for Render is pretty great. We're looking to add delta syncing. We did this for org. It's a little bit more complicated for decentralized rendering, but it's going to be coming to all DTC tool chains. And we are specifically working on improving the export process for these large caches that are going into Orbex exports for Cinema 4D and Houdini. So that's something that, again, we hope to have more news next few months, and maybe something shipping by the end of this year, maybe late summer, early fall. Phase 4, which is sort of the creative aspect of what we want to do with render beyond just the utility of what we're doing for making cloud rendering better. Well, there's a lot that goes into this phase of render, and that relates to IP rights and systems that you can build for trading and exchanging properties and assets through render. We can also do things that are related to low latency jobs and streaming. I mean, cloud gaming, for example, or app streaming. We built all these things for years, and in fact, we want to provide that as a next part of the service on top of the high latency work that render does today. And we're building an SDK that we're using internally that can allow you to build new extensions and new applications. We're going to be releasing that this year for new services. Also, render itself is a usage-based license to use Octane, right, on random nodes in the systems out there. We want to bring that into the actual core of Octane itself for existing customers. Imagine usage-based licensing powered by render. That replaces the concept of having to pay for your Octane subs. So we're thinking about that. Once we have more liquidity, Coinbase is looking at listing render, for example. That would be a big deal. Then we can explore those kinds of things. And realistically, it's probably something that we're going to have in some test form out there in the next 15 months. And in addition to supporting our own services this way, we also want to do this for third parties. So the Django FX team that's building Embergen FX, that's now part of an Octane sub, also interested in usage-based licensing through render. We even have a new tier called Render Plus, which is the beginning of exploring that. So I think you'll see a lot more things that are usage-based licensing, also exchangeable for render tokens this year. Super exciting. Now, I couldn't talk about phase 4 and all the things you could do with render if I didn't bring up NFTs. We touched on this a little bit last year. But we have so many artists now. I mean, I think at one point, 80% of NFTs were created in Octane, and a lot of them are being done on render. In fact, Pax Render that you're seeing here on the right, all done on render, including work for his recent Sotheby's auction. Of course, Mike Winkleman's been using Octane forever, and really helping us make render better. We'll sort of talk about all those things in a little bit as well. But we have the top Octane artists that are already doing NFTs in Octane and in render. And we want to build systems and to make that even better and trivial. So one thing from the start, the plan has been to get every single thing that you do on render to be turned into a token. And internally it is. We're just adding one button to make it so that you can turn anything in render. It could be a frame or a job or a collection or an image you upload or an asset you own or upload. And it'll turn it into an ERC721 token for a fraction of a penny. Won't burn down any trees. It's very green and eco-friendly. And any existing NFT that you've ever put out there, well, if you have the same wallet that you use for paying for render tokens, all of those are linked to your account. And you can then create something, let's call it an archive of materials that back up that NFT. So a lot of the problem with NFTs is they just don't have anything behind them. Even Grimes's video that was put out on IPFS, the blockchain file storage, it wasn't pinned correctly, and there's a broken media file. So I think one of the things that we want Render to do is to provide a tool for artists to have an archive of their work, validation of the work, even creating the work on Render and also turning that into an NFT at the same time makes so much sense. And towards the end of this talk, we're going to show some examples of how we're applying that in ways that, frankly, I think go way deeper and beyond what NFTs are currently thought of today, which are really, truly a token. Having the actual work itself created on the blockchain and also mixed and matched and with all the things we do with render on the blockchain, I think is the future of this space. So I talked a little bit before about something called XIO app streams. We've done so much work over the years, and this is a lot of it. A lot of it was for VR and with Oculus. This is Orbex Media Player, which was a media streaming application that we open sourced to Samsung and others. And it's really cool. I mean, this is it running in the Samsung internet browser, and you can load in pre-rendered Octane scenes, but they can also include streams, live streams from apps and different things. So we could take Octane Blender web page those things can be turned into a single NFT stream. You can even see here, it can be embedded in a web page. You can take the Atom demo and you can turn that into a token. And in fact, the actual JSON for the icons on the left are all coming from the system. And those you basically turn anything that's an app built in Unreal or Unity into a stream. That can be an NFT. These can be dynamic, very powerful. Everyone that's looking at how to take NFTs to another level, well, the tools are here for that. And you can embed them together. You can build a Orbex wrapper around a Unity app. It can run locally inside of a scene that's rendering as a GLTF in HTML5. It's incredibly powerful. And we want to essentially create the authoring tools for this system. It used to basically be a manual process that we internally dogfooded ourselves, but we're just going to add it into the rendered UX itself, so that you can create assets, pre-render things using render jobs, and then link them together, package app streams and put it all together. Whether or not it's an NFT or not, it's still something that we think is a very useful service for all sorts of things. So let's talk a little bit about the SDK for render, how we're going to build applications and develop on this amazing decentralized network. So the Render SDK itself is a fully portable API that allows us to do everything we need to do to create Octane in, for example. So Octane X, which is working on Metal and also on Vulkan and CUDA, it's all built in the SDK. And the idea is that you can use this SDK just like we do to support multiple platforms. And just like Octane itself is now just a module that's loaded in for a render job, well, anything could be that module, and you could build that with this toolchain, and it will work on any node on the render network. So we're sharing that with the Django FX guys and others so that they can leverage all these pieces. It also provides a really useful system. I mean, there aren't really tools that allow us to create something like Octane and ship it on Metal, ship it on Vulkan, on all these different platforms. It's really an important piece also as we're looking to allow people to build different renders that can be plugged into both Render and Octane. We want to have not just a system that allows us to be plugged in like we were doing with Arnold, but also the tools to create entirely new renders from source code, like for example cycles, and have that run on Metal GPU, for example. All these things become important. So here we have examples of these different devices all running the GPU cross compiler. And in terms of modules that we want to build besides rendering, physics, of course, procedurals, and of course rendering delegates via Hydra, all pretty important. And with physics in particular, we're looking at bringing in either the Omniverse physics system, which is pretty good, or Bullet or PhysX. Fortunately, there's a lot of standardization happening even in USD between Apple and NVIDIA, which we'll just be adapting into the core. Let's look at some of the modules that are being developed that connect back to Octane, including our first-party ones. I'll be showing Brigade a little bit later, but I'd like to take a moment to talk about Sculptron. So Sculptron, we teased that last year. It's a GPU sculpting tool, and we released a version that is free for Wacom tablets and users. And you can see here Sculptron's running on Wacom. It looks absolutely awesome. And it really is great. The 1.0 version runs beautifully on these Wacom tablets. Wacom's happy, we're happy. And Sculptron fills a niche that we didn't see filled out there around GPU sculpting. Yes, there's ZBrush for advanced stuff, but Sculptron is really fast. It's really simple. There's a lot of work that we're doing also in the coming months that are, again, features that we just don't see in other DCC tools. So because we're, again, and it feels very much like Octane, where we had this advantage of being a GPU renderer, we had to sort of think about what that meant. Again, with a GPU modifier stack, there's so many things we can do that are super fast. I mean, this is all running, essentially in real time. You have these great deformations and modifiers. It's incredibly quick for artists to develop in. And that's something that typically has been done on CPUs and the host apps. The goal would be that we actually integrate Sculptron and Octane together so you can render and deform and all these things all on the GPU at once. And I think once we have that system working, it'll be pretty cool. And we also, of course, want to bring this to iPad since we're already working so well on tablets. On Wacom tablets. So we also want to then have a driver of forces and fields, not just volumes and the like inside of Sculptron. All of that is coming, as is USD scene editing as well. Right now, Alembic is next on our roadmap. Last year, we announced this amazing partnership with JagFX. Talked a little bit about the project we're developing together, Embergen Effects. Embergen Effects takes JagFX's amazing fire and particle simulation tool all on the GPU. I mean, creates beautiful simulations like this. And it's currently free for all Octane users. We've had a very long beta period of Embergen Effects. I mean, it is obviously already pretty useful for production rendering, but it'll probably be free for a while longer, and it'll be built into all DCC tools later this year. And we're taking particular care to do this right in Blender and in Cinema 4D. Here are some of the new features that are in Embergen 0.75. It'll be coming to Octane and Brigade. You can see here animated meshes work, beautiful rendering right within Embergen. In fact, Embergen itself in the last year has gone really great at its own internal rendering system. And this is important because we plan to take some of that code, we have a source code license to Embergen, and really blend that nicely with Brigade. And of course, use that to inform how Octane's own volume rendering works. But if you look at how beautiful the real-time volumetric scattering system is now, I mean, it's gorgeous and it's awesome. So again, this is something where if you want to imagine how Brigade's volume rendering will work, well, it'll look a lot like this because, again, we imagine Brigade's volumes and simulations not necessarily coming from VDBs, but coming from live Embergen, graphs. And you can see here Embergen now works with dynamic meshes, looks beautiful. Add multi-scattering, which is something that's just been added in the last couple of months, in test builds of Embergen effects. It looks absolutely awesome. So, by the way, we're not just bringing Embergen to Embergen effects. There's a whole suite of tools that JagFX is creating for liquids, deformations, and explosions, and the like. All of that will be coming as part of your Embergen effects subscription. Last year, we announced another great tool that's part of the Octane ecosystem, and that is World Creator. Lots of World Creator and Octane users have been doing work that combines both tools for years. And here's some of that work. I want to play a beautiful video created by Aaron Westwood, top Octane artist, top World Creator artist. Check it out. Beautiful. Lots of great work done in World Creator and Octane. World Creator is included in Render Plus, which is a slightly higher subscription, but it also is going to be available for an extra $10 a month if you want to add it to your Octane sub. And the long-term goal with World Creator, as it is with these other modules, is to just make nodes that are integrated in the core of Octane so that it can be done right within the same tool. And that works in progress. I mean, it's probably, the rest of this year is going to be taken to flesh that out, but it's something that both teams are really excited to be working on. So we're not done with bringing tools into the Octane ecosystem and modules. We have one more to announce, and this is new. We're joining forces with LWCAD, and those who aren't familiar with the product, it's an amazing tool that does procedural modeling. So we're creating together tool called Architron, and Architron is a version of LWCAD software that will be integrated in Octane. It'll be available to all Octane subscribers, and it is used for polygonal modeling, NURBS modeling, Boolean modeling, and it's great for this kind of, all the things you're seeing here. It's an amazing system. You can see here it's running within Octane, in this case even in Cinema 4D. You can really use it to create fantastic procedurals like stairs and things that are fantastic for architecture. It can also be used for great Boolean modeling. You can see that on the left. If you want to create, window frames that are procedurally defined, again on the right, this is all showing how it works within, I guess it's a C4D here, and Octane, Octane's IPR. So again, we're making this free for all Octane subscribers. The two teams are really going to be working closely together to make this work in all DCC plugins, but initially it'll work in, of course, Lightwave, which is where the LW from LWCAD comes from, and it's Cinema 4D, and soon all the others as well. So again, we're really excited to bring this out. It'll be included in all Octane commercial subs, including Octane Studio. So for $20 you're getting a month, you're getting a lot more now than you were a month ago, which is great. So the suite of tools that are available to Octane users, all again targeting GPU rendering, GPU computation, keeps growing. and we couldn't be happier to keep adding more. So let's talk about rendering and extending Octane with other renderers, like we've been showing here with these different tools. So Multirender is a system that we talked a little bit about last year, and it's an important switch function inside of Octane. It allows us to switch to new renders from within the same Octane plugins that you have today as easily as you switch between rendering kernels. And we're using this to bring completely new renders into the system. Our first-party renders, Brigade, and the anime render, which we've been showing, those are things that we wanted to use initially. But we're also supporting almost any third-party renderer that'll be pluggable inside of your Octane plugin through Hydra, which is an API that Pixar has developed. And first up, we're using this for a non-photorealistic renderer, which we're calling just OTOY animate render. You can see here it's how it works. It's a GPU renderer initially built on optics. We're now porting it to the render SDK, so it runs on Vulkan and Metal and other things. But it's awesome. It's real time, and it does really great ray traced edges. And it's kind of our ongoing work that we're doing around non-photorealistic rendering, also making sure that works in real time. So we have high hopes again for this pipeline. And the way that we've ultimately decided to deliver this to Octane users is to build this as a full-fledged Hydra render delegate, and then allow Octane's multi-render Hydra render delegate loader to bring that into Octane Core and into all of our plugins. However, you can use the anime renderer on its own as a plugin into things like Houdini Solaris that allow you to load in a render delegate on the fly, and you don't even need Octane for that. So new this year, we can finally show this is Houdini Solaris, and this is the anime render running inside of it live, just directly running in there, and it works great. It's really great to see that running finally. So multi-render is something that actually kind of works as a process, both for bringing the renders that we're developing to any tool to support Hydra, and also within Octane Core. The other really important test case for multi-render is Arnold. So here's Arnold running in Octane standalone. I showed this last year as well in the fall, and we've been doing more work with this. But switching between Octane and Arnold right within the core with multi-render is instantaneous. It's also doing full material conversion. So you're seeing Octane materials running here in Octane being converted live on the fly directly to Arnold. The emissive materials, all those things. And as we work more closely with the Arnold team on converging our renders, that process is going to become even simpler and better. But there are some really interesting things you could do with both renders running at once. And this is something we haven't really seen in other systems. Even when you have, let's say, both renders as plugins to a DCC tool, it's not quite the same level of integration that we have with Multirender, where you can actually run both renders simultaneously. You can link them together, do compositing work with them. And since we have, in certain cases, code, or we have the ear of the the developers at Arnold, right? We can work with them closely on making this happen. And conceptually, if you wanted to, let's say, do volumetric rendering in one renderer and blend that with the solid rendering from another, which is something, by the way, we want to do with Embergen as well, this can all work. And with third-party Hydra renderers, beyond just Arnold, we have things like Pixar Storm, Intel Embry, less useful, but these things actually already work with multi-render. They're shipping out of the box. And I think since last year, we didn't show this. We had it in development. We now have Cycles. It doesn't have specular materials yet, but here's our first render with Cycles running inside of Octane Core with multi-render, both CPU and GPU. And once we get the material system up and running, Cycles will just be another modality in all Octane plugins. And because it's open source, we can probably bring that everywhere pretty easily. So the great thing about this system is it'll expose Hydra render delegates to every single Octane DCC plugin. That's over 20 of them. And we also can take any render that's out there. And people have asked about Omniverse, right? Those things could actually become render delegates in the Octane core system. And of course, for open source renders like Lux and Filament, Osprey, those things are like Cycles. We could probably do the work to bring those into multi-render ourselves. But there are two interesting cases, right, for other renders that people ask us about. A lot of people ask us about Eevee, and they ask us about Unreal. And because we have source code to both of these engines, we could basically build a module that brings in those two renders into multi-render. It's a little bit different than the Hydra render delegate system, but it is possible, and we're exploring that down the line. So let's talk about Brigade. That really was the impetus for Multirender to begin with. And Brigade itself is something that has a long and storied history. So I'll start by showing where Brigade began from. And I think this video is from GTC 2015, so it's 6 years old. But this was running on 80 GPUs on AWS. I think it was 80 K80s. So about 3,000 Octane bench was what it took to get to noise-free rendering, brute force. And Brigade is meant to give us path tracing and interactivity, but with no noise, and of course, ideally with that 80 GPUs. And it's a process that we've in different pieces we've brought that parts of that into Octane. But in 2019 we had a huge breakthrough with ray tracing hardware with our NVIDIA RTX. So we started by just recreating a special kernel, which we didn't ship, but it's been internally developed, which just took the input passes and ran those on RTX, and now direct lighting passes, which you're seeing here. And those things now run at 60 frames per second. And this work constitutes essentially one mode of Brigade, which is basically replacing Octane's direct lighting with something that's super fast, that runs great on a single GPU, which this is. And here you see it running with Multirender now inside of the core. And direct lighting Brigade mode is basically done. And we can now also test it and even ship it as a render delegate. So here you see it running inside of Solaris, like we were showing before with AnimeRender. And it's really a great showcase for RTX, because direct lighting is really just leveraging the RTX hardware as much as possible, but it isn't path tracing. So last year we showed the first results of the Brigade path tracer, and just like Octane has takes more time to do path tracing, Brigade is no different. Brigade's path tracer is actually completely separate rendering mode, and its quality is much higher than the direct lighting kernel I was showing before. And compared to Octane, 4 samples per pixel in Brigade gives you a much cleaner result. You can see that on the right versus the left with Octane. And in practice, that means that you're getting, on the very same GPU, on the right, you're seeing 60 frames per second, noise-free rendering. On the left, the same scene on the same GPU with Octane. You're getting near real time, but you're getting a lot of noise. And that is distracting from look dev or even final frame rendering, right? If you can deliver final frame rendering at the speed you're seeing on the right, why not? So last year, I don't think I showed this last year. This is showing how Brigade works. Like, it does take a little bit of time to converge, like a split second. But when it does, when you let it go and you get to a final frame, it looks good. But it isn't. It is a progressive render like Octane. It's just so much faster that it just gives you these results very cleanly. So you can get to final frame rendering. You can do IPRs that are essentially noise-free. And that system is very powerful. So, Vlado was speaking about this in the panel we were doing earlier in GTC about how, the spectrum of rendering is an important thing for all render engines to consider. And that's the case for us as well. We see Brigade itself as a spectrum extending Octane to new modes for faster direct lighting modes, for this mode that you're seeing here, which is, path tracing, not quite Octane quality, not all the features that Octane has. I would almost say what you're seeing here is the medium quality mode of Octane, of Brigade. You're seeing all the features we have in there, including, as you're showing before, caustics, and you have IOR and all those things running really fast. But there is an even better version of Brigade that we're working on that's higher quality, slower, maybe 60% of the speed you're seeing here, but it's really, really close to Octane's spectral, unbiased rendering quality. And I think that if we didn't do that, we would be missing out something. We want to give you, the artists, the modes to have all these different speeds and quality settings available, essentially with sliders or just from a UX dialog box. And this work with Brigade is really important. It's probably the sweet spot for speed and quality, but we want to go lower and higher than this as we develop this further. And one day we may see the higher quality mode for Brigade, which we're looking to ship inside of Octane 2021.2, delivers everything that we want. So this is a stress test for this, for this version of Brigade. This was showing mesh lights, which are really hard to render, and it's going maybe 6 to 10 frames a second. But it looks pretty good. Now there is a little bit of splotchiness. This is a new version, new this year, and it's much faster, even higher quality. So we've made significant improvements in terms of the quality for the hardest corner cases inside of Brigade. It's important to test what we're doing with real scenes, and this is an example of that. I would say that exterior scenes with Brigade, which you're seeing on the right versus Octane on the left, the Brigade as it is now in this form does a great job. I mean, the scenes really do look so close. It is harder artistically to get Brigade with features that are not in Octane to render at this quality. It's a little bit of tweaking, but once you're there, it delivers absolutely stunning results. We have such great stuff in there for the medium node, for example. I mean, it's just instantaneous. On even more advanced scenes, again, these are outdoor scenes, and scenes that also, by the way, do well with RTX. This is the Octane 3 splash screen. Again, the quality between the two renderers is pretty close. This version didn't quite have all the mixed materials working, so that's why there's some black textures there, but it looks great. On the left, you see the same GPU running the scene on Octane on the right. I mean, there's just no comparison. The Brigade scene is just running at incredible speeds and incredible quality, and there really isn't a visual difference in this case. So Brigade for these scenes, the outdoor scenes with tons of instancing, I mean, everything that makes RTX on much faster with Octane is going to run great inside of Brigade. Where limitations are currently, as I pointed out earlier, are with interior, scenes, things with lots of interior lights, mesh lights. Those things are tricky, but they work. And I think that, again, there's just like with RTX being something that is scene dependent, you're going to see Brigade's speed and even the quality that it gets, be scene dependent as well. And I think that in the case of scenes like this one, outdoor scenes, daylight lit scenes, I mean, you're probably just gonna end up using Brigade for final rendering because it looks good enough. It looks really good. So another important thing that we've added in Brigade is the environment node is completely, the environment medium node is completely rewritten. And it gives you the things that you have in Octane for volumetrics at a much faster speed. Not quite the same quality, but still good enough. And things like God rays are simpler and faster to render. There's a little bit of noise, but it's pretty good. And of course, you have full dynamic lighting. I mean, nothing is pre-computed or baked in anything that you're seeing here. Here's another great scene. This was the Octane 2 launch video. Really massive scenes with tons of instancing. Again, an outdoor scene, but the quality between Brigade and Octane is really close. Speed, though, is not. Like on the left, you have the Octane version. On the right, you've got the Brigade version. And the speed on the Brigade one is pretty awesome. And this is running on a 2080, by the way. This is this is actually under the average speed of the Octane users' 2080 Ti card, right? It's just fantastic. I mean, I was making these videos and just having a blast because it really does give you a final render for something that used to not take a split second 2 years ago. And for scenes like this, I think we're done. I mean, it's such a joy to be able to have the IPR and the final render finally be one thing, and we've been working towards that for a long time in Octane and Brigade. I mean, my goal with starting OTOY was to get to cinematic rendering in real time, and Brigade makes that possible. This is 4K 60 running on a 3090 or an A6000, and it's just beautiful. I mean, it really runs full speed at this resolution. This is the famous God ray scene. This was the Octane, I think, 2 splash screen. Beautiful God rays. I mean, instantaneous in Brigade. Again, the medium node is really powerful. Speaking of volumetrics, this is Embergen effects running inside of Brigade. Excuse me. Instantaneously. So the idea is that you're going to link your Embergen simulations live inside of Brigade. We can now move those simulations around. That's new since the last GTC. And those are all really powerful features. I mean, I think we're also going to take a lot of the rendering that's being done in Embergen and just leverage that inside of Brigade and blend those together. I mean, our partnership with JangaFX is for the long term, and we want to make it work beautifully together. One thing that I haven't shown before is Brigade running inside of a DCC tool. Other than that quick test with Solaris, this is it running inside of Cinema 4D. And it runs great. In fact, I think it's limited really by the Cinema 4D viewport. I mean, Brigade's running as fast as OpenGL. Now, this isn't running through the Octane plugin. We just built a special purpose Cinema 4D integration just to test how fast Brigade would run. And it's super fast. I mean, it's basically, it at least proves that there's no bottleneck between doing this dynamic path tracing that we have at Brigade and the DCC application. Eventually, as we move Brigade into the core of Octane, we won't need to be doing these specialized tests. It'll just work in all DCCs. I want to talk about another feature inside of Brigade called Light Cache. And I talked about this earlier when we were mentioning that PPM was going to be used to do a radiance cache. Radiance cache is still something that we want to leverage, again, for certain use cases where real-time is of utmost importance, and shading, even the shading we're showing with Brigade, is just not performant enough. And this is the case currently, for example, on low-end devices that we could run on, like iPads and iPhones, where we want to have ARKit, for example, render scenes like this one with the least possible amount of shading. And sorry, run this again. And you can see here in this video, we're running with the, it's a version of Brigade that's adapted to ARKit, and it's using that irradiance cache, and you're getting this beautiful render live in ARKit. So again, this is generated by the PPM kernel, a test version of that in Octane, and it's being used, great effect here, to allow you to render quickly on a low-end device. Now, we should also mention that we actually have the full version of Octane now running on these devices as well. So we have, again, the spectrum of Brigade and Octane running on iPhones and iPads, but we do see, the iPhone itself being augmented by what's being done on the cloud. We finally, by the way, have Octane X running on the iPad. And yeah, the speed's incredible. It is crazy to see on an iPhone 11, this is last year's model, it's about 50% faster on an iPhone 12. You're seeing the speeds that you would see on an Intel MacBook. The iPhones are really powerful, and ultimately you can do final frame renders from the iPhone, which is great. Now, 13 Octane Bench isn't a lot. That's why our goal is that you can kick off your render jobs from an iPhone or an iPad to render, where you can then have 100,000 Octane Bench power the end of your job. But we can also do interesting things like turning your phone into a render node and powering that as a extension to your existing device. So lots of interesting opportunities there. But truly, this work is in service of what we can do on the iPhone with Octane X and Brigade and render on AR. And when you mix these together in ARKit, things start to get really interesting. So this is a keloid scene using Brigade with the irradiance cache running in ARKit on an iPad. And this is about 13 million triangles, so it's not a lightweight scene, and it is running live in ARKit using the irradiance cache to deliver these absolutely gorgeous results. You can see there's ray trace reflections and everything in there, but it's GI, secondary bounce, all of that is handled in the irradiance cache. So good enough, fast enough for this to run in real time. Again, when you think about what NFTs could be doing with this, right? If you wanted to have it, create an NFT that is not limited to what you can do in inside of Octane, then this stuff is really pretty important. And here we show the relighting system inside of the Octane SDK. And with relighting, you can do some really powerful things in AR. You can actually have the scene itself provide diffuse lighting. This is a system that we see being used, of course, for really advanced renders like the one you're seeing here. So this is running in Octane X with live relighting being driven by the the environment that's being captured by the camera, and it looks absolutely gorgeous. Pretty amazing to see this kind of rendering be done live on the phone. And all of this is being kicked off from a pipeline that begins with Octane. There's you can do some of this through render as well. You can just generate an asset, and this is where, again, the convergence between everything you're seeing here and a blockchain-based verified asset like an NFT could be leveraged. Again, an OctaneRender you saw before, you can take a piece of that, turn that into an ARKit object that uses all this tech to provide an experience that you can run live on your phone. And again, if you wanted to run that live now with Octane on the phone, it is all possible. But our ARKit rendering in Octane X is getting really good. That scene now, last year we could start to do close-ups of it, and it looked really great, as you're seeing here. There's also motion blur, which we just recently added. That's also being done live. Makes the scene look a lot better. Ultimately, where do we see all this going? Well, we have Octane X as an app now on the App Store, on the Mac App Store, but that'll soon be out on the phones and the iPads. And the idea is you can do scenes like this, which was done with Cinema 4D on the desktop. But ultimately, if you can render this live on the phone and you give this tool to millions of people, you might see beautiful works of art created this way. Even top Octane artists, I think, would love a tool like this. So we see that being part of a brand new pipeline for AR. The trend for content creation, I think, going forward is don't discount mobile devices. And I think this is relevant even for companies like NVIDIA that are doing making huge investments in ARM-based CPUs, right? I mean, that's what's powering an iPhone. You can see the Urbach scene on the left, the ARKit version on the right, running Octane. It looks absolutely beautiful, really great. Fun things you can do in ARKit, of course, that leverage this technology. It's kind of limitless. So I'm curious to see myself where things go with mobile. I mean, I think the fact that NVIDIA is buying ARM is going to lead to some really interesting developments in space. Going back to what I was mentioning over the last 5 or 10 minutes, all the things you've been seeing here and NFTs do converge. There's no doubt that if you're going to sell an object and have the ownership of it, you want to have something that you can view not just in an image, but potentially in a volumetric way. And I had this slide from my presentation last year, which was showing these different examples and use cases of assets from scans and 3D models, and even here's a Beeple model, all running as ARKit objects. And this brings me to a larger point, which I want to close out on, which is I think that the use case for render beyond NFTs is pretty deep. We see render itself, I mean, since so much art is created already in the tools that we're generating, we're supporting multiple pipelines, we have multiple renders. I think we want to create an archive for artists to be able to create things, verify those things on the blockchain, and create a system for their own works of art being permanently stored for posterity. And that could be a basis for NFTs as well. So we're testing out an idea that I had for this going back a year with some partners and close friends. And of course, that earlier tweet I mentioned was calling out Alex Ross and Beeple and Pack and others around these ideas. And everyone's deeply involved and invested in this success of this idea. So the very first render archive that we're doing is Beeple's. And you can go to x.io, beeple.x.io, and you can see it's Christie's piece backed by IPFS. The interesting part is that we're not stopping at just CG work. We're also taking all of Alex Ross's materials, his paintings, his work, and we're also putting that into a render archive that'll be handled through render, and again, a basis for future NFTs. So I'm going to start by almost going back a bit to a slide that I keep showing towards the end of these talks, which is, do we need a truly open metaverse? And the answer is yes, we do. And this slide shows a bunch of interesting artwork from Alex and others, especially this painting here, which was one that was created specifically for a project called The Metaverse with Alex, and it was delivered to J.J. Abrams. And this painting represents a really interesting inflection point in my work as creating OTOY and Octane and working with Alex. And in fact, that painting is now in a book called Art Unseen by Alex Ross. So not only is it hanging on a wall somewhere, but it's also an important point of how Alex and I both see the metaverse evolving. And in this book, if you go a page further and you read here, you'll see a paragraph written by Alex about this project. And this work, these archives that we've been building go back many, many years, almost 20 years. Alex, in fact, was working with OTOY around Render the Metaverse, a contest we did for Oculus around Octane art. And the concept behind this work was to create pieces that almost were an ontology of all the different mediums out there and all these different channels. And if you look at the body of Alex's work that's going into this render archive, and by the way, the piece on the right is an original work that is going to be his first NFT. The pieces that we created, the original pieces, really were blending these different mythologies, these different universes together. If you take everything he's ever done, it almost covers all of the pop culture of the 20th century. And so it's just an amazing piece to sort of explore how art that could be backed up on the blockchain can be more than just the art, but also the ontology, the graph that links these together, the way a render graph works. And a lot of the work around the project itself, of course, is meant to archive his physical work. And there's a huge number of these physical paintings. But the ones that we actually created specifically for the Metaverse project, which were original pieces that OTOY commissioned, which you're seeing on the bottom left here, those ones we scanned in at super high resolution, ran them as render jobs on Render, so that we could then have a link to XIO that you could then see in AR. And top left, you're seeing these ODG glasses, which don't exist anymore, but are really high resolution. So if ever you see Facebook or Apple probably put out AR glasses, it would be something like this. Those paintings, looking through those glasses, when they were linked in, looked like the real thing. The bottom left is the actual raw scan. super powerful to consider works of art being represented this way and having something like the blockchain being used to define where they get seen. And of course, now with NFTs, the idea of art on the blockchain is something that now is valued as highly, at least monetarily, as traditional art. Looking at Alex's work, though, there's a lot more than just taking his paintings and his drawings. There's actually, as you can see here, a bust of Spider-Man, top right. Let me take a photo of his collection of actual sculptures and models that he's commissioned and created for Superman and the like. So we've actually been scanning in those assets on Lightstage. We showed that with the Green Goblin bust. And for the last 20 years, building CG models of his paintings as well. So those things are all going into the archive as well. And those CG models are really great. They're also used as a basis for taking something that would be associated with, let's say, buying a lithograph or painting of Space Ghost, right, and getting something in CG that you could then turn into an AR object. Again, NFTs, imagine buying this painting from Kingdom Come and having this asset come along with it, and having the asset itself be something that can be linked into a render job, a render graph. There's hundreds of these different assets that have been built this way in the Alex Ross archive that now have sort of a place to be put out into the world through XIO and through the render network. Here's a Lightstage scan from a painting, which you see in the middle, and of course the test on the left of a light field render. It could also be a full-on, local render like we were showing earlier. This is an amazing piece, by the way. This is his father scanned it on the Lightstage in 2008, turned into an Orbex file. So again, his father was a character in the book Kingdom Come, Norman McKay, and we scanned him in, turned him into a 3D file. Render archive, and everything we've been showing with this tech is, used to sort of preserve that for posterity. And there's a lot more work to be done. Lots of characters, including this interesting one that's going to be showing up in a Marvel comic book, interestingly enough, next month. It's just never ending. And the work that Alex has done over 30 years truly is a map of the metaverse. Just looking at this collage, by the way, which people helped us make. You have so many different windows into different worlds and metaverses, almost metaverses of metaverses. I truly think that if you're going to crack open a way to link artworks together, create methods and systems that create ontologies where those can be linked together, this is the way to do it. Of course, we have to talk about Beeple. This NFT you're seeing here, the render archive for Beeple truly is that piece. It was a collage of 5,000 of his everydays. Most of them, certainly the last 7 years, were done all in Octane. And the Beeple Render Archive is something that I think will make a lot of sense to anyone using Octane today and thinking about getting into the NFT space, which now, of course, is thousands of artists. So the work that Mike and I are considering, that we felt was really important, that we started talking about back in November when his NFTs were first selling, is we have to take things beyond what NFTs are today, which is just an image, right? We need to document, in the case of the Render Archive, we want to document a lifetime of his work, all 5,000 of these pieces. And Mike's done that. He's diligently done his best to provide these images you're seeing here, which shows what tools were used, Cinema 4D, Octane, Photoshop. That's basically a starting point that we want to take further. We want to be able to take those Cinema 4D files, the Octane files, even the Photoshop files, put those in the Render Archive like we're doing for Alex's work, have an NFT be backed by that so that we can do things like re-render it and take it further than just having a flat image. That's the future of blockchain art, I think. So another example here is, let's see, this is his everyday from November 30th, 2017. And we want to take this as an example. Here we have an Orbex that was used to generate the render on Render. That render job itself could link to an NFT for this piece. Again, there is one NFT from Christie's that linked together all 5,000 of these works, but Mike's actually been selling those individually as well. And the NFT for this particular piece can now have all those things that Mike linked his images to, on Render. So you can, if you own the NFT, for example, you can open up the Orbex file or the C4D file and do things with it. All of this is verified by Render. It can be used to kick off another render job. For example, if you wanted to include this scene in your own OctaneRender, well, you can download the Orbex as a proxy, and it's verified, and Mike can create a system around that. Any artist can. Or you could just have it be locally rendered on your phone. And NFTs can be a whole new flavor of utility when you have the scene file itself verified by the system, used to create a piece of art, and having remixing and interoperability exposed this way. Of course, you take that one step further from having an Octane Orbex downloaded to even a phone and just have it running all in ARKit. Well, then you end up with this, which is what I was teasing earlier, where you have the actual NFT for that everyday running entirely in ARKit. This is, by the way, a proxy that was generated from the render job and downloaded to the phone from an XAO link. So again, the future is pretty interesting for NFTs that are linked through this system. And I think Mike's been amazing in sort of the thinking behind how this could work. I will say that one of the important considerations that Mike has for the future of his work, both NFTs and otherwise, are linking back to the physical world. So that piece is something that is offered, for example, for sale on a canvas in a physical frame. And the true part of the render archive is also physical. I mean, here's a couple of photos that Mike shared with that Christie's piece actually shipping in a crate, life size. The thing that he and I both identified as being pretty important is shipping a physical object to owners of an NFT, of a piece of crypto art. And in his case, he created this OLED display, shipped it in a box. And that points to where the future of NFTs are going from his perspective and from mine as well. And in his case, we're going to be leveraging holographic displays, right? So we're already generating render jobs that could be used for an image. We're generating these assets that can be used for local rendering, ARKit. But truly, art that is rendered on a holographic display is a whole new level. That is something that would transcend art on canvas. And it's such an important part of the future of what we're trying to do here. And Lightfield Lab is providing that technology. They are literally building huge displays that are going to power holodecks of the future. We've announced this partnership for about 2 years now. And the way that they work, I mean, in large form factors, they can be used to provide holographic concerts. You can have holographic tables, holodecks in particular. But this was a demo that Mike and I actually were reviewing years back. I mean, when we were testing things on the holographic display, there's only one of them, right? Here in LA, we would run it through a projector, do eye tracking, and you can see what it looks like to look at a piece. We're showing this earlier on ARKit on a holographic display. Now, granted, this is simulated, but that's what the experience is. That's what the feeling is. So if you imagine an NFT that is only viable on a holographic display, then the work of art on canvas analogy becomes pretty strong again. And the displays themselves are now almost ready for production. 20-inch by 20-inch panel is 51K by 49K, so 2.5 gigapixels. Huge render, about 1,000 times more rendering is needed than you would for an HD frame for a 20-inch panel. But it'll look absolutely beautiful. And given the price that some of Mike's NFTs are selling for in the millions, it's not out of the question to have these NFTs be powered by holographic panels. This in particular is one of my favorite experiences on the older panels. I mean, that scene looks like something I've never seen before on any other display. You can't really generate that with auto stereo or even AR or VR. Your eyes converge on the depth in that coat hanger and the door in ways that are just incredible. So I would imagine a high density, collage of people's work all within a, on a single, holographic display panel would just be incredibly compelling. And it's truly a tool that artists can use to create all sorts of novel experiences. The panels themselves are 20 inches by 20 inches, but they can be linked together to any size display. It's like the Samsung video wall. It could just be infinitely large. And that's, again, how you get to sort of a concert level or IMAX size holographic screen. The larger the screen's surface area, the larger the volume that can be projected in and out of the holographic display surface can be. So again, going bigger is better, but even a single 20-inch panel is really compelling. By the way, those panels require 16 A6000s to power right now. It's a lot of energy, but so 10,000 octane bench to just drive it live. But ultimately, this is the future, and it is truly leading towards the Star Trek holodeck, which is one of the things that OTOY's wanted to be part of that process for a long time. Holographic rendering, holographic displays. Frankly, really inspired when I saw Countered Farpoint, the Star Trek: The Next Generation episode in 1987. And going back to square one, the next archive that we're doing is the Gene Roddenberry archive. Rod Roddenberry is my best friend, investor in OTOY, and we've been working on this project for many, many years. It is different than the other two archives I just mentioned. There's a lot of materials Of course, Gene is no longer with us, but this archive is meant to celebrate, his 100th year birthday, which would be in August. And of course, there's photos, there's models, there's a lot of materials that are going in there. In fact, there is genuinely a Roddenberry vault, you can see it here in the middle, that's been used by CBS and Paramount to provide behind the scenes materials for the Blu-rays. But the team that's been working with Gene for years, including Michael Kuda, who literally has written the Star Trek Encyclopedia, is working with us on organizing all this stuff, creating something that frankly doesn't exist on Wikipedia or on the web. So many materials from Gene's work, and even some of the blueprints that we're using to build CG models of, for example, the Enterprise, all those things are part of this project. And providing this system on the blockchain permanently is something that really does need to get done. There's a lot of resources that have been done in books and materials out there that just don't really have, maybe you can search them on the Internet Archive, but they're really, not extant. So the point of putting this perpetually on the blockchain and also creating amazing assets is the goal of this, this work, which is going on for years and probably going to continue for about a decade to come. And here's a tease of some of the things we're building on Render for the Gene Roddenberry Archive. And as the end of Star Trek: The Motion Picture said, the human adventure is just beginning. And I want to close out by thanking everyone in the amazing motion graphics Octane community, the CG community, working with you as developers, as creators, as partners. I mean, it's been incredible. And truly, what we've been doing in the GPU space has been, a joint effort between customers, artists, creators, developers, and of course, NVIDIA and everyone else. So we're grateful to be part of it. We're grateful to see the future of GPU rendering, expanding by leaps and bounds every year. And we can't wait to see you next year. So thank you. This is Jules Urbach signing off for GTC 2021. Take care, everyone. See you next year.